Fewer crane lifts, fewer berth joints, less surveying, less time in the dock. Welcome to this explainer. Today, we're looking at something massive, specifically diving into subchapter 5.2 on megablock assembly and efficiency at scale. We're going to see how the world's most advanced shipyards have completely rewritten the rules for assembling the largest moving structures on Earth. As you'll see, the megablock strategy doesn't change what is built, it totally changes how efficiently it gets assembled. To really understand the sheer scale of this operation, let's just look at two numbers, 150 versus 15. In your standard approach to shipbuilding, a yard might have to perform about 150 separate crane lifts just to move individual 200-ton blocks into a building dock to assemble a whole. But the megablock approach, it shrinks that number down to literally 10 to 15 lifts total. The secret? They're lifting gigantic 2,000-ton megablocks. This strategy absolutely drastically changes the efficiency of assembling a ship. Okay, let's dive into this. What exactly is a megablock? Well, it's a massive single unit formed by pre-joining multiple standard blocks together long before they ever reach the final building dock. I mean, we're talking about a totally self-contained section of a ship spanning the full beam, so from the port side all the way over to starboard, and stretching across all decks from the keel right up to the upper deck for a 20-meter length. The scale of a single 20-meter-long piece of a solid steel ship being moved as one single object is, well, it's absolutely staggering. So how do they do it? By pre-joining 5 or 6 separate blocks early on, we completely eliminate multiple crane lifts and berth joints later down the line. This pre-joining assembly happens in an adjacent, highly controlled workshop area. Now, the yard still uses standard block erection techniques, but because they're in a controlled environment indoors, the conditions are just way better and productivity goes through the roof. The ultimate goal here is prepping one giant, fully integrated 2,000-ton unit for the dry dock. Now, what's really interesting about this next point is the sheer muscle needed to make this happen. To pull off this incredible feat, a shipyard needs massive lifting capacity. We're talking 1,500 to 3,000-ton gantry cranes, or sometimes even larger. Without this monumental hardware, the megablock strategy is basically physically impossible. You simply cannot lift a fully integrated, multi-deck section of a modern supertanker as a single piece without it. No way. Because of this intense infrastructure requirement, it creates a pretty highly exclusive club. You know, a standard shipyard operates just fine with 300-ton cranes handling 200-ton blocks. But megablock assembly requires a massive infrastructure leap, up to 1,500 or 3,000-plus ton cranes just to handle blocks weighing 2,000 tons or more. And because of this massive upfront capital requirement, this method is primarily used only by the very largest, highest volume shipyards in the world, specifically those mega yards in Korea and China. So you might be wondering, why spend all that money on giant cranes? Well, it all comes down to the economics of scale. Those massive upfront crane costs are entirely offset by saving literally weeks of dry dock time at high production volumes. Think about it. The dry dock, or building berth, is the ultimate bottleneck in any shipyard. It's the gate. It dictates exactly how many ships a yard can physically produce in a given year. So minimizing the time a hull spends occupying that dock is the absolute key to profitability. You get the ship in, you get it built, and you float it out significantly faster. Let's zoom in to the micro-level secret of this efficiency. Here we can see just how dramatically the number of required joints drops. 150 individual blocks mean 149 incredibly difficult berth joints to connect them all out in the dock. But 12 megablocks? That means only 11 difficult berth joints. Every single time 2 blocks meet on the berth, it takes an enormous amount of time, labor, and precision. By dropping from 149 joints down to just 11, the shipyard is effectively bypassing one of the absolute most time-consuming hurdles of traditional shipbuilding. To really understand why bypassing those joints matters so much, let's just map out the agonizingly slow steps of a traditional, grueling berth joint process. When 2 blocks meet out in the dock, you don't just start welding. First comes a precision alignment survey. Then comes the fit-up, where they're actually using hydraulic jacks to painstakingly nudge the massive blocks into exact position. After that, full penetration welding in a really awkward outdoor position, followed by post-weld inspection and potentially heat treatment. The megablock method brilliantly demonstrates how much labor and time is saved simply by avoiding this grueling sequence over 100 times per ship. So the crucial point is this. The mega block strategy essentially moves difficult berth work to easier workshop work. That is the core thesis here. Actually, to put it simply, you aren't doing less welding to build the ship, you're just shifting those bottlenecked, difficult dry dock welds into a protected, highly ergonomic assembly workshop environment. Inside, the productivity is way higher, the weather isn't a factor, and the conditions are simply much, much better. Ultimately, this paradigm shift doesn't change what is being built. It fundamentally changes how it's assembled. It drastically reduces crane lifts and surveying time. Sure, those heavy upfront infrastructure costs for those giant gantry cranes are huge, but they yield massive time savings over the life of the yard. And most importantly, that dry dock bottleneck we talked about, it's effectively bypassed. It's a brilliant operational move. Shifting the most intensive work to assembly areas completely revolutionizes the heavy shipbuilding industry, allowing for some truly incredible scale and speed. But this brings us to a really fascinating edge case and a provocative question to leave you with today. What happens when a ship is actually too long for the building facility? Even with the incredible efficiency of megablocks, what if the sheer design length of the ship exceeds the length of the shipyard's massive dry dock itself? Well, it sets up an audacious concept, building a mammoth ship in two completely separate halves and then perfectly joining them together while they're floating out in the water. It's an incredible feat of alignment and engineering, but, well, that's a story for another time. Thank you so much for joining me for this explainer, and keep looking for the blueprints behind how our world is built.